Hello Aurora lovers, I am DaleBoan from DaleBoanImaging, and this is Aurora Hunting 101. This is episode 16, How do I use SpaceWeatherLive.com? SpaceWeatherLive has one of the most complete collections of aurora information of any sites. This can be good, and it is also potentially confusing. Also, it is not a dedicated aurora site. It is a space weather site, so it has a lot of additional information related to space weather, primarily related to the sun. Let's take a look. So this is the SpaceWeatherLive.com website, and it's got a bunch of things, but in terms of information, the two primary ones are the solar activity. So if we look at real-time solar activity, that gives us information about the sun, and as aurora chasers, we can completely ignore that. But it's also there's some interesting things on there, so I'll come back to that. Mainly what we want to look at is auroral activity. Now, if you're using the app, it just has two tabs at the top that allow you to switch between the two, and then a sub-menu that lets you go into these some more detailed options. Unfortunately, it does seem to have a growing amount of advertising, so we'll try and ignore that. So just like most apps, they have the current KP index here as the first item. So if you've listened to some of my earlier videos, I'm not a great fan of KP. It's got a weird definition, and it's not the greatest for Northern Lights hunting, but it's still useful. The biggest problem with it is for a fixed time period. So right now this is for 1500 to 1800 UTC time, and it will be the maximum value for that 3-hour period. That period never changes. It'll just go on to 1800 to 2100 for the next period and start with a new maximum. And that works okay if the KP is going up. You'll see those incremental increases because it's showing the maximum. However, if it's going down, you won't see any change because it'll lock at that maximum value. So if it's going from 5 to 3 in that 3-hour period, it will stay at that initial 5 and never drop. That's just the way it's defined, and it's defined over those fixed 3-hour periods. It's not the tool we want, but it's one of the primary tools that we have. If you want more information, you can see under more data, you can see the current KPs is over the last, 2 days, I guess, for each of the 3-hour periods, what it was. You can see that it is generally trending down. This was last night, where we got up to KP 5-. Unfortunately, where I am, it was pretty cloudy. And most of the activity happened actually in the afternoon. The other thing is this auroral oval map. This is not, so right now, there's basically this little green patch way down here by that Antarctica is the only place they're predicting the aurora might be visible. And then, the dark part is night side, and this is the rest is sunlit. Personally, I don't like this layout. I don't like this a flat map. I find it really hard to read. I prefer this map that's on the from NOAA. Can I make this smaller? A little smaller. And they've got the north and south poles. So this is the Aurora 30-minute forecast. We also call this the oval a lot of the time. And Like this is a nice view of North America, which is convenient for me being in North America. Maybe if you're in Europe, this isn't your favorite. NOAA's in the US, so that's probably why it's oriented this way. I want to start a petition to have them add the Canadian provinces for Canada. That would be really helpful for a lot of new people. So this is, it comes up with the current, most recent map. And I think it'll come back to this. But you can actually, if you hit play, it'll play back in time. Or actually it'll go back and play the last 24 hours or more. So that was the KP5 that happened yesterday. And then it dropped down. So you can see what they're predicting as a possibly visible aurora. In my experience, it's fairly conservative. And now it's pretty much nothing is visible. Maybe a little tip of in Russia. This terminator is a really hard line, and really dusk is not a hard line like that. So I prefer this, the 30-minute forecast of the Aurora Oval, over the one that's on SpaceWeatherLive. But you can use it. It's usable, especially if it's very active. Coming down here is real-time satellite data. So coming from the Discover satellite. This is interesting. There's really only one piece of information in there that you should pay much attention to. So if you're watching KP, the second most important thing is the BZ. And I have another video dedicated to the BZ, so I won't talk too much about it. So this is the north-south component of the solar wind magnetic, north-south magnetic. The solar wind has carries magnetism with it, so it's got its own magnetic field, and it's broken down into X, Y, and Z components for the 3 dimensions, because it's a 3-dimensional field. When the BZ is north like this, so that's the north-south component of the field, it is consistent with the Earth. So it's north, and the Earth's magnetic field is north, and that allows the solar wind to more easily flow past the Earth. When it's negative or south, there's much more interaction between the solar wind and the Earth's magnetic field, and more of the energy gets pulled into the Earth's magnetic field, creating more aurora. So that's very, if you're following KP, BZ makes a tremendous difference for a given KP. It's probably equivalent to a KP change of plus or minus 2, depending on what the BZ is. BT is the total magnetic field, so that's the overall strength of the field, and the BZ is 3.5, which is, only half of the overall magnetic field of 6.18, approximately. So it's north, but it's not strongly north. It's actually pointing someplace else. And it doesn't even show the X and Y axis because they really don't affect the Earth very much. Density is how much material is coming. Nice to know, typically 10 plus is a positive thing. Well, I've seen aurora at even lower, like 0.01 or 0.05, maybe, probably not 0.01, 0.1, 0.05. Sometimes it shows that there'll be aurora. Wind speed is how fast the solar wind is. So the Discover satellite is at the L1 Lagrange point, if you want to be technical. And it takes right now 55 minutes for the solar wind to get from the satellite to Earth. And of course that changes as the speed of the solar wind changes. As it speeds up, that time will go down. If the wind's really strong, that might be down to 30 minutes. It can be over 60, but it's fairly slow right now. And you can see it just updated again. This updates very frequently, every minute or 5 minutes. And you can see the trend. That's the wind speed is dropping, density is maybe sort of dropping, it's sort of bouncing around. Magnetic fields aren't really changing. So, but you don't need to understand that. NOAA calculates this. This is the hemispheric power, and that includes all that solar wind information in real time, and the hemispheric power is a much more accurate prediction of what the auroral activity is right now. And here they call it the hemispheric power, and they give you this nice graph. If you go back to the 30-minute aurora forecast, that's the HPI that's up in the corner here. So if we scroll down to here, we've got 10.5. Lead time is 52, so this might be a little bit out of date because it just updated on the other one. Here we're at 55 minutes. So if you wonder what the Earth line is on all of these graphs, so this is the measurement that was taken at the satellite, and 55 minutes later, this is what's actually happening at Earth. So it's showing that travel time from the satellite to the Earth. And hemispheric power has the same idea. It's not shown as clearly on here, but it is mentioned here, this 52-minute lead time. I guess there's also time to calculate, right? And if you ever dug into any of these things, I think all the data gets moved around by text files. And then the text files have to get processed and calculated. That's just the way the world works behind the scenes. So, and then the current value is here. There's north and south hemisphere. It's not obvious, but the north is top half and the bottom is bottom half, just like there's north and south here. They usually don't differ very much, and you're unlikely to be in the southern hemisphere watching the aurora. Disturbance storm time index is more a technical thing. I don't really understand it. But I wouldn't say I understand it completely. But the basic idea is it's trying to show the accumulated energy building up in the Earth's atmosphere, or Earth's magnetosphere, to see if it's building up to a storm. So KP, if we go all the way back to KP, KP is a measurement of how much distortion is happening in the Earth's magnetic field, and that's done using magnetometers. So really KP is, they take a bunch of magnetometer measurements, take the maximum over that 3-hour period, and that's KP for that period. Not so good for real time. And they're magnetometers that, if I remember correctly, down near the equator, equatorial magnetometers. So here we're showing the ones that are publicly available in Canada, or part of the CANMOS Canada network. So when these turn red or orange, there is much more variation in the magnetic field where those are. You can see that sort of drifting around, and then they color it when there's more fluctuations. Like here you can see there's bigger spikes in these darker colored ones. I don't find that very useful, but that's actually where KP is coming from, is those measurements of magnetometers scattered around the Earth. And Sweden's got one, Europe's got several. They're just organized differently by the different science groups that run them. Hobart on Tasmania has got one. You don't need to know it, but that's what that graph is showing you. Moon phase, the moon interferes with visibility. Right now it's a new moon, so which is perfect. And then from now on, the moon will, in less than a week, the moon will start interfering with aurora observations. So new moon, the moon is going to start rising just as the sun sets. Well, in the summer not so much, but approximately. So that's mainly what you know about SpaceWeatherLive. I look at this. I look at the forecast. So this is just the min and max, which isn't as helpful. I don't know if they actually have the, oh, they have their aurora forecast here. So this is the predicted one going forward, I believe. Yeah. Problem is this is UTC time. This is one of the reasons to use the app, because it should correct to your local time or another app. They do have the evil long-term forecast. My recommendation is just ignore this. I'm going to do another, actually maybe even the next video on this, but this is based on the sun's rotation and where active regions are on the sun. It's not a very reliable predictor. This one has the moon phase, which is really useful. That's about it. And more ads. So that's sort of the same information that most apps have. This has got a bit more. The hemispheric power, for example. This and the 30-minute forecast are the only places I know of easily accessing those. If we wanted to go look at the solar one, so we can see the sunspots. So more sunspots are generally good. 3363 is the one that just produced a giant flare. It's in the news here. This M57 flare, flare / CME, and it's notable because it erupted for almost an hour. Usually they're like 5 minutes. So it pushed a whole lot of matter out into space, but it's sitting down on this edge, pointing away from Earth, so it's 50-50 whether it's actually going to hit the Earth or not. Coronal holes, right now there isn't, but sometimes there are black spots on the sun when looked at it with, I believe this is ultraviolet. And that's sort of the opposite of a CME, an eruption from the sun. It is a weak magnetic area on the sun, and it's so weak that the outer layer of the atmosphere drifts off into space. If it's facing Earth, then that often drifts into the towards the Earth, and we get aurora generated from that. And it can be fairly long-lasting, but maybe not quite as dramatic as a CME. And you can see sunspot regions and how many sunspots are in each of them. And the type matters quite a bit, whether it will generate. Alpha ones are pretty stable. The beta gamma, beta delta ones are tend to be more active. So the other thing you might want to look at, so we heard that there was a big CME. We can go take a look at it. So these are the latest ones detected by this cactus. So most CMEs do not interact with the Earth. They aren't Earth directed. And the ones that potentially are flagged under halo. And the bigger they are, the higher this Roman numeral is. So category 4 is wide angle, so it's sprayed all over the place. Potentially full halo CME. Those are the best kind, because that's a direct hit on the Earth. So it's a halo because it's basically forms a ring. From our point of view, it forms a ring around the sun. So it's basically coming straight at us, or almost straight at us, enough that, you know, it creates a ring when we look towards the sun. Of course, if it's 270 degrees, that's almost a complete circle. Getting close. A lot of them are closer to type 2. They were just 90 degrees. But you can see that a lot of CMEs are not Earth directed, or even potentially Earth directed. The one thing I wish they would say is this is which sunspot region they're coming from. They say the time, and you can correlate it back, and then you can look at the pretty pictures. So that's a picture, and then there's a graph, which is not worth spending my time interpreting, and then you have these animations. So that's, I think that's, so that is a very big CME. Oof. So right now the sun is very active, and we're getting Earth, or potentially Earth-directed CMEs most days. So that's always good for Aurora. When it's less busy, it's maybe a little bit more important to look at this if you're curious, or you can just wait for the forecast to come out. Solar photons, don't really care. That it'll go up. That's basically our solar protons. That would be hydrogen atoms stripped of the electrons. That would be a proton. Solar flares, people mix up CMEs and flares. Flares is the burst of light. They're actually both generated by the same mechanism. It's a magnetic reconnection in the Earth's magnetic, or in the sun's magnetic field, and it jumps, and that jump causes photons to be emitted, creating a flare, and the force of that can also cause part of the sun to get ejected into space, creating a CME. And this is just the activity. Yay, more ads. So these are all the solar flares. This is that big one yesterday, and had another fairly big one today. This is a logarithmic scale, so as they go up, it's not going, difference between here and here is not a little bit, it's a whole lot. That's x, 10x, right? And we have had X class flares recently, but they didn't really, I don't think they were Earth directed. But you know, the more you know, the more this all starts making sense. But at the starting level, just look at this or use an app. But like I say, hemispheric power is, in my opinion, the most useful thing you can look at night, which is the main reason I use this website. So in summary, SpaceWeatherLive.com is a really useful site. Unfortunately, the solar and Aurora information is separated onto different pages in both the website and the app. And then, as always, for current conditions, I always say look at HPI over KP, and that's one of the primary reasons to use SpaceWeatherLive.com when you're Aurora hunting. And that's why it's one of my favorites. And that HPI is calculated off that real-time satellite data, so you don't really have to pay attention to the satellite data. It's just always interesting to see what's going on in space. And then the other reason I might look at it is to see if the latest CMEs that people are talking about, or the news media is talking about, is actually Earth-directed, if there's a potential halo there. Although usually I just wait for the forecast to come out from NOAA. With that, please check out episode 17. What is the 27-day forecast? And I'm wishing you clear skies and happy hunting.